Right, so I'm going to talk about cloud native applications and actually how to test them, and I'm not a tester, so eventually there will be some testing questions that I have no idea about them. Right, so what I do know about is about cloud native, how to build continuous delivery pipelines, and you will see all kind of stuff that we build in this ecosystem: Mesos, Kubernetes, Nomad. I do know when Rocket was announced. It was just the day before DockerCon in Amsterdam that we helped organize in Docker, and it was 2014 November. Yes, so it was, and it's currently built mainly by some German company working for CoreOS. But who didn't hear about Docker? Okay, good. This time it's different. Who did hear about Docker? Then, yeah, still. So some people don't know. Okay. I'm not talking about Docker. Who cares, right? It's like we are talking about orchestration and services. So first, what is cloud native actually? So there is this foundation called Cloud Native Foundation in Linux Foundation, which is one of the collaborative projects within Linux Foundation. It was started about a year ago, I guess, mainly by Google. And the main goal is this doesn't work. So it's about distributed applications with self-healing, scaling, multi-tenancy. But basically we're talking about distributed systems. So we are trying to build distributed systems. And most of this talk will be about how you actually build or mainly how you test distributed systems, which I can kind of reveal the main idea. It's fairly difficult. So you probably can kind of recognize this picture, at least this part of the picture from original Docker presentation. But the idea is that if we take 50 years, history 50 years back, we will see monolithic applications and all these big systems, big hardware and big software systems running with like a one big chunk of stuff. And further we go, smaller things become, but also more complex. So basically trying to distribute them among, let's say, cloud server, in the beginning it's monolithic, then it becomes client server, and today we're talking about clouds and microservices and all kind of other things like that. So basically the pieces of the software, the pieces of the system become smaller, but we have way more of them. And today the main idea is microservices with some possibly reactive UI running in multiple clouds. And of course this is not the end of the story. It will continue dividing itself and creating more and more complexity. And we can show it in a way that kind of biological, right? So the things become smaller and like cells, they divide, but the complexity of organisms or whatever you call them, kind of software organisms, become bigger and bigger. Right, so then cloud native is basically about taking these big systems, or more and more complex and bigger and distributed systems, and putting them somewhere inside the cloud, and whatever it means. So today we know probably two, or you will recognize two major approaches to do that. The first one that exists for a while is called 12 factors up, which is not microservices. It's a bit different. It's a very opinionated set of microservices, you can call them. So if you follow 12 rules, then the life of distributed system you are building will become actually your life, while building a distributed system will become reasonably easy. Microservices is more flexible, but also more complex. It's basically you do whatever you like, but there are still good rules to follow. And essentially 12 factors up are, 12 factors are good factors to follow, good rules to follow. at the end, what we actually want to build is continuous delivery pipeline. The same way as we build continuous delivery pipelines for simpler systems, we want to do the same for complex microservices. The problem is that when you create this microservices and you're only testing a simple or small piece of it, then it doesn't represent the entire system. So you actually need to set up the entire setup, the entire system, the entire distributed system with all the parts and test it. And if not, then you are in the same way as somebody who is developing software and integrating every 4 weeks and end of the sprint or something like that. So essentially you need to test the entire distributed system all the time, continuously, and hopefully deliver it all the way to production. And from our perspective, we have no testers. From my perspective, they are like, testers are kind of not irrelevant. They possess the domain knowledge of testing, how you do tests in the right way. But essentially, all the tests are executed by developers, created by developers, or executed automatically, but created by developers as part of development process. So yeah, again, we as a company, we don't have any testers, and we'll never do. We will never will. So now, from now on, I'll just tell you about some of the projects we built in the last couple of years since the company exists, and using those examples, we'll show at least our findings, our ways to test, or our ideas how to test these things. Probably if you already started doing anything around distributed systems, you will not find anything unusual about them. So first, by far the biggest project was done with collaboration with Cisco, and it's a combination of 2 projects, actually kind of 3 projects, but we were only involved in 2 of them. And the main one is Mantle, and another one is Shipped. So Mantle is a kind of cloud management system, and Shipped is continuous delivery to deploy to that cloud management system. So essentially, it's a platform, it's a combined platform to build and maintain microservices. Actually, originally it was called Microservices Infrastructure, until we decided it's not the best name, not the most catchy name to use. So the first project we built was ElasticSearch framework for Mesos. And this is the first example of a distributed system, which is ElasticSearch, running within another distributed system, which is Mesos framework, running on top of another distributed system, which is Mesos itself. And they're all different things, and they all behave different ways, and they kind of run on top of each other, but they don't really fit, right? They kind of like, they have different logic. ElasticSearch is absolutely different cluster management tool than Mesos. The problem was in the beginning that when we started, there was no really good way to test it. The only way was to create Mesos cluster, and at that point, it was about 1.5 years, 2 years ago, the only way to create Mesos cluster was to just start it locally in a bunch of virtual machines, or deploy it in the cloud. In the beginning, we just created Terraform model to deploy it to Amazon. So it saves some time, but it still takes 5 minutes. 5 minutes means that you cannot do it all over again when you have a single problem. So if you destroy the cluster, then you're screwed, right? It's terrible. 5 whole minutes to start again. It's terrible. It's like not acceptable. Anyway, later we kind of been missing all these parts of let's say all this list of things. You don't really need to read all of them, but the point is that if you work with systems like let's say JVM, right? JVM is also kind of virtual machine, and you run things inside. But when you work with JVM, you have a bunch of tools around JVM, like compilers, debuggers, tracers, IDEs, the entire ecosystem of stuff that you can use and get all of it running. If you work with Mesos, there is none of it, like nothing. So if you start writing a Mesos framework, which is kind of application running on Mesos, you start from copy-pasting something that doesn't work. You need to understand internal protocols. Until recently, there were even no HTTP APIs. So it was actually a client, like binary client, linking with other things and doing all kind of weird stuff. So the first thing that we did was to start building MiniMeses. It started from actually DrCompose to start a bunch of containers and run Mesos inside. But eventually it actually became a tool on its own. So it's a Java application that starts a local Mesos cluster. And it's kind of Mesos DrCompose just for Mesos. So since it's in containers, obviously it is very, very quick, like 5 to 10 seconds to start up the cluster. So when you get to 5 to 10 seconds, it means that every time you can just start a new cluster, install your framework, and start debugging. Debugging is still very difficult because you have 6 containers and you cannot debug across multiple containers in a synchronous way. So it's difficult. So the main point of MiniMeses was to create this, which is, I'll show it later in real life, but basically the idea is to create start Mesos cluster and then test if it started, which is integration with JUnit, and just run the entire integration test of Mesos framework every time starting a new Mesos cluster. So that's how you would expect to start to do testing in a non-distributed environment. Yeah, so today MiniMeses integrates with Jenkins and Travis and all kind of other tools, and there is a Maven plugin and CLI and configuration file and all kind of other things. So it actually became an open source and fairly full project, although we don't that much actively develop it anymore. Right, so next project was actually 2 projects. One was, so as you remember, we built the Elasticsearch framework. And of course, Elasticsearch coming with Logstar and Kibana. Right? That's the whole point. So we were building logging framework for Mantle, which is a cloud management tool. So the ELK was, we already had the Elasticsearch, which was the most complex framework. And then we had to have Logstar and Kibana framework. Kibana framework is trivial because it's just one container. You don't even need to have a framework, actually. It's overkill. But Logstar, it's a bit different because you need to install a single Logstar instance in each machine, which is kind of against Mesos logic. Right, so that's how it looks like. It actually doesn't matter. The architecture doesn't matter. The point is that now we have Mesos, and then on top 3 Mesos frameworks, and they all need to be tested together, and that makes it even more difficult. Right, so the next project was, I tend not to use this kind of images, but this one was just, I mean, a monkey in a computer. It's, of course, Mesos monkey is like Chaos Monkey from Netflix, I guess. Yeah. So, and it does what the normal monkey would do. It's like chaos, right? So it breaks things. And that actually, we never open sourced it for some weird reason. We kind of forgot. We were thinking we should, and then it never really happened. So you cannot really find it, but if you need it, ask us and we'll give you access to it, or maybe open source it at some point. But this is a very useful way to make sure that your thing works, right? So it's less relevant for monolithic applications because just killing it is not like, it doesn't create too much excitement. But in distributed systems, it's really important because you really find all these race conditions and all these weird things that come with distributed system. And you need to do it all the time, consistently killing your things and keep doing it. Right? Yeah. Okay. So it does all these things, all these ways to kill things, but basically it does damage. Right. So using all this experience, actually not just this, but also other things, we recently we worked on a project which is not a real project. It's a demo application for a company called Weveworks that typically building network and visualization for containers, but they needed an application to show in conferences and generally show to people how to use containers, because actually no one really knows how to build microservices, or very few people. There is no good example that you can copy paste. Like 15 years ago, there was this thing called Pet Shop. So it's like a web application that if you run it, you create a very simple shop to sell food for cats or something. Now, this is essentially the same thing. It's an attempt to create a demo application that you can copy paste and based on that create microservices. It has a bunch of services, I think at this point around 14, in 3 different languages with different databases and all kind of things. Now obviously it's overkill for a socks shop, right? That sells like 5 types of socks. But that's not the point, right? It's a demo application, so you learn and experiment and build on top of that. But of course, it's a real microservices application with all the different pieces and all what comes with microservices. And we needed to use all the experience we had from building Mesos and Kubernetes stuff to actually build this application. This is number of services. And actually, those are actual containers running in the system. So WeaveScope is a tool to visualize the containers in your system. So when you start this thing, then those are the containers running. And it can run on Kubernetes, Mesos, directly on Amazon, on Nomad, and all kind of other things. So in this application, we are using these levels of testing, and not all of them fully implemented yet, as the entire application is not fully implemented. But of course, there are levels of testing, and higher you go, then faster it becomes. So now just quickly go over each one of them. So when you do unit tests in MiniMeses in microservices, essentially nothing changes. Your unit test is not even aware that it is running in the context of microservice, right? It's about functions, testing functions. So in a sense, nothing changes. Component test is essentially, again, nothing changes. It's too small because it's within the service. So, okay, then whatever tool you use, whatever test you use is the same. Now, container test, since our applications, our microservice application that we're building are always running in the containers, essentially our distributable artifacts are containers, container images, and not jar files or something like that. So it means that every time you create an image, you need to test it. The way to test it is to start the thing, create demo, basically mock dependencies, because a single service doesn't live on its own, so you need to mock the dependencies, mock the data, and do whatever. So there is not a lot of difference still. Where it comes to actual difference between testing regular applications and microservices is basically this, is testing APIs. So now we have 14 services. In our in simple case 14 containers running, but in reality each container is a cluster, each service is a cluster, so potentially you can get to hundreds, thousands, or tens of thousands, or whatever. You can start 1 million containers, right, in 5 minutes. But there is huge amount of communication going on between these things. And the biggest problem in microservices so far, as far as we understand at least, is broken APIs. Right? So when the companies, when the teams are not following the rules, they are not preserving APIs, then really chaos happens. Essentially, there are contracts between consumer and producer of the APIs, and those contracts need to be followed. It's like if we are between us, if businesses have contracts, if you don't follow them, then it's not very good for society, right? All kind of weird things happen. Now, it doesn't mean that it never happens, but you really, really want to reduce these things. This is very similar to changing change of APIs, like function names in normal programming languages. If you do that, if you own one component out of 50 in your company, and you just change the name of the function that every other component using, and by linking to your component, and you never tell anyone, and you just release it, and you just submit it to Git, and then somebody builds it, really bad things will happen, right? So everyone else will need to refactor their code, but you need to let them know in advance, otherwise there will be a downtime. So essentially this is the same thing. When you change an API, then it's like changing the name of a function. We are using Dread, really.
Is he or? Okay.
No, it's just this time is my fault. I forget to enable. No, anyway. So we're using Dread and Swagger to define the APIs, and Dread to test them and make sure that they're as agreed. The next thing is integration testing, and so we strongly believe, regardless of distributed or not distributed systems, every developer should be able to test the entire system, or at least as much as possible, with some emulation, with some whatever dependency. Somehow create a local environment that is reasonably close to production environment. And the fact that you have a distributed system and you're only working on a single microservice doesn't mean you're allowed not to create the entire environment. So we strongly would recommend to create local testing environments using tools like DrCompose or MiniMeses or Minikube. Minikube is obviously MiniMeses version of Kubernetes. And there are also, so essentially testing environments become similar to version control. So each developer has his own view of Git, but there is also collaboration. So through Git you can collaborate and share the code. So the same thing eventually somehow will happen with testing environments, that they will be shared, but not one developer or the entire company, but more like a team sharing local environment that is distributed between their laptops, or partially running on cloud, partially on their laptops, or something like that. So we don't have anything like that, but we had plans to run MiniMeses in distributed way. Essentially start all these containers. It's actually 6 containers. MiniMeses include 6 containers in standard configuration. So we were thinking to start a single master and agents on different machines. So this way you can actually create a team setup where you can deploy different services to the same setup without actually going to the cloud. We didn't do that. So, and of course there are advanced testing strategies like stress testing performance, those are not unusual. Then chaos monkey, all kind of different types of monkeys, gorillas, and whatever. There is a lot of new tooling around distributed tracing and monitoring and logging and all kind of other things, because they are all very different from traditional tooling. And of course there is even more advanced microservices specific tools like A/B testing, blue-green deployments, canary releases. All these are different flavors of advanced cloud-native testing strategies. So, if you want to ask me or our team what kind of big things you really need to do if you want to test cloud-native applications, then those are the things. Is build your private testing environment where you can set up the entire thing. Test your APIs properly. And have CI and hopefully CD set up. Now, there is a very short demo so this is a MiniMeses website, right? And it has, you actually can do it on your own later on. It has interactive tutorial, actually a bunch of them. And this one is specifically for JUnit automation. Size right. So this is the point I was showing earlier. So basically, I'm setting up the cluster, MiniMeses, Mesos cluster with some simple configuration, some port, zookeeper, master, whatever I need for that thing, and then run a single test. If Mesos cluster can be started, good. If not, the typical testing thing. So I'll go through this thing. So this is my code, which is basically a test, Mesos cluster test. This is in Java. Most of it is written in Java. The Maven file. Right, so now I can say just run Maven test, right? So in this sense it's just normal testing. But so it will build the application, create a Docker container, and start a fully functional distributed Mesos cluster, deploy the thing inside, run the tests, and then return basically is unit test or is the system test passed or not. It will take like a minute or two, but eventually it will be fine. And that's about it. Questions?
I've got a question. Do you use any kind of configuration management software?
Configuration management.
Yeah.
Git is like fine.
So you are just using Docker files and something like that?
So everything should be version, of course, which means sources, Docker files, and then Mesos files, and then MiniMeses files. There is a lot involved. So right now there is a process of simplifying these whole setups and creating less files. But at this point, every single tool has a bunch of configuration files, and your goal is to create programmable infrastructure, essentially create the entire thing fully from sources. So you're checking out from Git, and you have a bunch of commands, hopefully just one, and then everything is running.
Okay, one more. Nope. Okay, we have one more.
So this application you're building for the SOX company is going to be open source?
They are not SOX company. They're the opposite of SOX company.
I mean,
Yes, yeah, but
the example based on the SOX.
yeah. So it is an open source project. It's totally open source. You can look for SOX shop or Weave SOX shop, and you'll probably find it. Yeah, that's the whole purpose of it, is to make it available for everyone so you can learn from it. And we are blogging about this and writing some stuff and talking about this, and we are also trying to convince Linux Foundation to adopt it as a standard microservices cloud native setup. It may happen, it may not, but something like that will come to the market to basically show people how to build microservices.
Okay.
It is open source, yes.
Anyone? We'll leave the rest for the after body. I think yes. Okay, so thank you, Pini, for your talk. Applause, please.
Thank you.